All right, let's talk about one of the most exciting technologies, like technically, philosophically, like socially, financially, in every way, which is Ethereum 2.0.
Hmm.
There's a million things to talk about, but at the step one is probably a good thing to do, which is, can you briefly summarize your vision
Hmm.
how Ethereum 2.0 will make Ethereum more scalable, secure, and sustainable?
Sure. So I think recently we've actually been kind of de-emphasizing the ETH 2.0 branding, I guess.
Hmm.
So the reason behind that was that originally we envisioned something more like a big grand event where, all the good things would happen at the same time, and
Yeah.
it would be a new blockchain, and it would be a new protocol, and people would have to take a lot of effort to migrate over. But later we've slowly changed the roadmap over to something that's much more incremental. Right. So, proof of stake happens kind of over time, and then sharding gets added over time, and all these features get added over time. And so the experience for just a regular Ethereum user still feels very seamless, right? It's like maybe a little bit more complex than the hard forks that we've already done, but from a user's point of view, but like not by that much, right? The big two things that are happening, right? These are what used to be considered the two flagship features of ETH 2.0, and now they're just, the flagship features of the next evolution of Ethereum.
Yes.
Yeah, as proof of stake and sharding. Right. So proof of stake is a consensus algorithm. It's or consensus mechanism, I should say. It's the difference is that like an algorithm is something that you run by yourself. A mechanism is like it involves like interactions between people, and it could even include incentives and all of that. So a consensus mechanism, so by which nodes in the network agree on, which blocks came in, which transactions came in what order, make sure that once a block gets accepted, it can't get reverted, and all of these things that we expect from a blockchain. So existing blockchains, including Bitcoin, including the Ethereum of today, and including a lot of them, they use proof of work, right? So the reason why we need proof of anything is because like they serve this function that I call kind of economic Sybil resistance. So that's obviously a big word for, especially if you've never heard of Sybils before. But like the basic idea is right that you have a network and you have lots of computers that agree on like which block to accept,
Hmm.
and sometimes you get two blocks that get published at the same time, and you just have to agree in an order. So there has to be some kind of voting game. Yeah, but then the question is, well, in this voting game, who gets a vote, who gets to participate? Now, you can't say one person, one vote, right? The reason why you cannot say one person, one vote is because you need some kind of like authority or some kind of mechanism to say, who the humans are, like, and if you don't have that, then a bad guy could just come in with a virtual machine or with a computer that has on it 10 billion virtual machines that have 10 billion, virtual nodes, and then just like say, look, I'm 99% of the network. I should control everything.
Hmm.
So to prevent this, what proof of work and proof of stake both do is they basically say, well, the weight of your vote, like how much influence your votes have in the consensus, is proportional to like what quantity of economic resources you bring in. So in the case of proof of work, you prove what economic resources you have because your economic resources are computers, and you prove that you have them by just running them 24/7 using these hash algorithms, right? So this does solve the problem, right? Because in order to attack the network, you have to come in with more computers and like more money invested into computers and electricity than the rest of the network put together. And that's extremely expensive. In proof of stake, instead of relying on people with computers that are just constantly cranking out hashes 24/7, as your like unit of economic resources, you just use like holdings of coins inside the system, right? So all of these blockchains, they have some kind of coin in them. Bitcoin has Bitcoin, Ethereum has Ether. They all have a coin. So why not just use that as the economic resource that you're using to like measure participation? So that's like the core distinction between proof of work and proof of stake. I like proof of stake, and I've liked proof of stake for many years, basically because like it just requires much less ongoing resource consumption. right? Like with proof of work, you have to like actually go and buy these physical computers. And these days, they have specialized hardware, ASICs, application-specific integrated circuits. You have to go produce them, and you have to go buy them. And unless you have millions of dollars, you have to buy them from one of these other people who creates them. And those other people often end up taking a huge cut of the profits themselves. And then you have to plug them in. You have to just burn all of this electricity that's just running 24/7. So it consumes a huge amount of energy, right? And and not just energy. It also, just to create the hardware, right? Like people focus a lot on energy, but like actually about half the cost of proof of work mining is the cost of the hardware. So hardware is a very big deal too. And you need this really big and powerful, like very specialized hardware, the kind that fills up these big warehouses. So proof of stake, you don't really need that much electricity. You just need just a little bit to run a regular computer. You can run proof of stake validators on computers that you already have. So it's just much less resource intensive. And like this is good for a few reasons, right? Like one is, the kind of environmental rationale that, you're not breaking the environment. The second is that you're not taking away electricity and like other resources from other people, right? Like I think just today I saw a story about like Iran wanting to shut down some Bitcoin mining because it was just grabbing up so much electricity that it was, outbidding the nearby towns, and they just didn't have enough. And then there is like Chia, the one that's doing proof of like hard disk mining, basically is just like grabbing up so many hard disks, so there's a shortage, right? So that's the second reason. And then the third, more selfish reason is that because participating in consensus does not require so much energy expenditure, you don't need to pay people as much to participate, right? So like Bitcoin and Ethereum, they both issue somewhere around 4% of the total supply every year right now to miners. So Ethereum is about 4.7 million Ether, and the current supply is about 115 million. But with proof of stake, like we expect it'll be somewhere between 500,000 and 1 million per year. So that means the supply doesn't have to increase so quickly. So
one of the pros that that people sort of argue for the proof of work is that it is secure because it's much more difficult to sort of, as you've highlighted, is difficult to participate. Is there what are your thoughts about the security of the proof of stake mechanism? Is there ways to make it secure?
So I think proof of stake is very secure because in order to be able to attack the system, you need to have like basically as much stake as the rest of the network, right? So that means like right now, for example, we have 5 million ETH staking. So you have to come up with 5 million ETH and then join the network. And then the other, so 5 million ETH is a lot, right? It's like, how much is it now? Like $15 billion. So that's actually more than I believe the cost of attacking the Bitcoin network. And then the second thing is that recovering from attacks is much easier in proof of stake than in proof of work, right? Because in proof of stake, you have, like, first of all, we have, for many kinds of attacks that you do against this network, we have this concept of like automatic slashing, right? Which basically means that in order to like revert a finalized block. So if there's one block that's like accepted by the network and you try to convince the network to kind of revert that block and accept a different block, in order to make that kind of attack, you basically have to have your validator, like a big portion of your validators, sign two conflicting messages. And this is something that, like, once these messages are on the network, well, you can go and prove, like, look, these people did it. And so we have this feature in the protocol called slashing, where you basically take all these people who provably misbehaved and you burn their coins, right? And you don't burn anyone else's coins. Now, there are other cases, like, for example, if instead of reverting blocks, the attack just tries to censor everyone, right? Then what you do, everyone who got censored would just like basically create the minority chain. And then the community would basically have to do a soft fork, right? They would just have to say like, look, this chain is clearly attacking us. This chain is the one not attacking us. And so we're going to join this chain. And then what happens is that on that new chain, the attackers also lose a lot of coins. Right. Yeah. So the difference between proof of stake and proof of work is that in a proof of stake system, like you can identify specific participants and you can say, these, and like this isn't like, a human going in and saying, I don't like you, I don't like you, I don't like you. This is like automated, right? You can
the slashing process is automated.
Yes.
Is there ways it can go wrong? So that's a painful process where the coins are burned.
It is painful, yes. I think, I mean, the one big unknown, of course, is like if an attack actually happens, and like if an attack happens that requires the community to actually choose one of these minority forks, then like what would the community actually successfully coordinating on this look like, right? Like it's like, we can talk about it and we can, write like science fiction novels about it, but like until it's happened, you don't really know the details of like what it looks like and how difficult it is.
What are the channels of communication for the community? If you can enlighten me a little bit, like what, you
Mm.
know,
Hmm.
in many ways in the political realm,
Hmm.
Twitter is often used as a way to kind of have these emergent phenomena of
Hmm.
large groups of people coming to a consensus
Right.
about a particular idea, and
Hmm.
then there's battle for consensus. What's
Hmm.
in the Ethereum community?
Hmm.
How do people? What are the sources of natural language based communication that have an emergent belief structure that you would
Hmm.
say? Or is it all
So
through money? Is it all through trading that the
no, I think
communication happens?
there's definitely talking as well. I mean, like we have to agree on protocol changes somehow, right? Like there's Twitter, there's Reddit, there's GitHub, there's all of the various Ethereum forums, Ethereum magicians, Ethereum research. There's just in-person communication. Then there's just kind of like the hidden web of everyone talking to everyone on Telegram,
Yeah.
or Signal. So it's like some of everything, right? But I think like the thing to emphasize around like can you actually come to consensus on whether or not to fork the chain because the attacker is censoring everyone, just for example, is like everyone who's running a node is going to see almost the same thing, right? Like they're going to be off by a few seconds, and like maybe they'll be off by a few minutes. They'll disagree by a few minutes, but like if it's a serious attack, people are going to know, right? It's not like one of those things where, we're trying to agree on like, I don't know, did Epstein kill himself or like some, random
Yeah.
political fact where like in
Yeah.
reality, no one knows a single thing about what's
Yeah.
actually going on and they're all speculating. Like it is much more visible, right? So we do have that, but at the same time, I'm happy to admit that like these are fairly untested mechanisms,
Mhm.
but like at the same time they're also untested mechanisms in proof of work, right? And like in proof of work it's even harder because in proof of work you don't have the ability to like identify and say like I'm going to these miners attacked and so we're not going to let these miners in, these miners did not attack so we're going to keep them in. Like you have to pretty much either take out none of the miners or you do a fork that changes the proof of work algorithm which takes out all of the miners, right? So the economics of like recovering from attacks in proof of work, at least to me, actually do seem like more unfavorable. But I'm sure the proof of work people you talk to will give very different and contradictory opinions, and that's totally fine and amazing.